Let's call it real numbers revision part 2. Okay, we did one set of revision on Monday. We're doing the second set now. The first thing is finding a square root. Okay, finding square roots. Okay, I want you to put this side heading. Okay, if there is, and I will just demonstrate one example. Okay, suppose I have a number which is, let's say I have let me calculate something. Yeah. Okay, suppose I have 196. Yeah, and somewhere I have come to a position after during my calculations in my, suppose my Pythagoras theorem or some other equation I'm solving. It is a quadratic equation, and I've reached this situation that x square is equal to 196. Okay, now when when I go to the next step, x becomes equal to, actually it becomes equal to plus or minus root over 196. Okay, but we're going to leave this concept of plus or minus for now. We will touch it back when we study quadratic equations. Right now just we need this for length purpose, right? In trigonometry we need it for length purpose, so all the lengths are positive only, so we're going to take that positive root. Okay, so if you did not understand that, so okay, all right. We will cover this topic when we study quadratic equations. Right now, x is equal to root over 196. All right. Now this, to do this, take, I have to first prime factorize 196. Okay. Now I can see it is 6. It goes with 2. Uh, what comes here is 9. 16 is 8. 98. It goes with 2 again. Then it comes 4. 18 is 9. 49. 49 we already know is 7 square. 7 7. 7 7 is 1. Yeah. So I reach this situation, and then x becomes equal to, so in under root I'm going to write 2 into 2 into 7 into 7. Okay. Whatever is here. Okay. Basically, what is this? This tells me what 196 is equal to 2 into 2 into 7 into 7, right? This is what this thing tells me. Now, as per the way we learned in 8th class, what I have to do is just club in pairs. Okay, if there are two 2's, I can write a single 2 outside. Okay, outside the root I can write. Same way, there are two 7's here. From this I can write a single 7 outside. Yeah, and multiplication symbol continues there. So x is equal to 14. Okay, we good so far? Anyone has any doubts here? Anyone wants to check something here? All right. Now this was one example. Okay, let's call this is example 1. Okay, if you I'll give you some time to take things down if you need. You can continue taking things down simultaneously. Yeah, because it's something we are just revising, right? Let's take one more example. Okay, let's do here. Let's call x is I'm just going to leave this part because I'm just going to jump to this step. Okay, so suppose you have somehow reached y is equal to root over square root over let's say 40. Okay, square root over 40. Okay, very simple. Now here same process I'm going to do. Okay, 40 2's are divide by 2 we get 20, divide by 2 we get 10, divide by 2 again we get 5, divide by 5, because we are just using prime numbers, as we all know. Here we should only use prime numbers, and better start with smaller and go bigger. Even if you take a bigger prime number earlier, it's okay. Finally it will all be in multiplication, and multiplication is commutative, so we can swap. So what we have here is 40 is equal to 2 into 2 into 2 into 5. Yeah. Now this means under root, I'm going to write 2 into 2 into 2 into 5. But as you can see, here we don't have a clear pair forming. 2 into 2 is one pair, but 2 into 5, there is no pair forming there. So what happens is I pull this out of the root, I write it outside root. Okay. The remaining thing, since there is no pair being formed, I cannot take it outside this root symbol. Okay. And I'm going to touch upon the reason in a bit in 1 or 2 minutes. But right now I cannot take it outside this root symbol. So what happens is I write the root symbol as it is and I write 2 into 5 under it. Yeah. I write the root symbol as it is and I write 2 into 5 under it. Basically, I can just multiply 2 into 5 and it becomes 10. Just for simplification, I'm going to write 2 root 10. So y is equal to 2 root 10 in this case. Okay. If there are more such pairs, you take all the pairs outside. Okay. You take all the pairs outside, it's basically multiplication here. Okay. It's like 2 into root over 5 into 2. Okay. We good? Any doubts here? Yes, I want to check. Can I get a fist to 5 in the chat box? If where you are, what you're doing, what are you feeling about this? Can I get a fist to 5 in the chat box? Okay, I'm seeing most of your hands giving me thumbs up. Okay, anyone who has a confusion, can you please unmute and speak? Has Tulsi joined yet?
Sir, she asked for Gita Manjari.
She asked?
Leave, sir, to Gita Manjari.
Oh, okay. Fine. Because by 9 o'clock she had not informed. Anyhow, cool. So, thank you guys. I am seeing that we are all feeling like we are at a good place, right? Now, the question comes of how does this work, okay? And we take it to the exponents part, right? What is happening here? So actually what is happening is, let me take another example, okay? Anyone wants time to copy this stuff down? Anyone wants time to copy this stuff down? I can give you a minute if you want. Please unmute if you want, otherwise I'll move ahead. Okay, go ahead, Dinesh.
Sir.
Okay, continue copying. Yeah, I'll just come back in 1 minute. Yeah, copy. Everyone done copying? Whoever is copying, shall I continue?
Yes, sir.
Okay, moving on. Yeah. Now, how is this working actually? And for that, we need to realize the concept of exponents. Okay, we remember exponents, right? Now, in exponents, there were lots of laws, but I'm not going to touch all of them right now. Okay, right now I'm going to just touch one of these laws. Okay, which is a to the power m whole to the power n is equal to a to the power. Nishchay, can you complete this?
MN, sir.
Mn. Okay. Basically, if a power, if one thing is raised to another power and it already has a power, the powers get multiplied. Okay. There are lots of other laws. Right now, we need this law for this question. Okay. So I'm just going to do that. If some other law is needed, we'll touch that also. Okay. Now, what's happening here is, so when you say uh, y is equal to root over, now let's take this only, y is equal to root over 40. What you actually mean is y is equal to 40 Raised to the power, anyone remembers? Riza, can I hear from you? What does it mean? Y is root over 40. What does it mean in powers? Riza, do you know? Do you remember?
No, sir.
No, remember. That's okay. Y raised to the power half. Okay. Just like that, when I have y cube, suppose I have y is equal to cube root of, uh, let's take 17. What it actually means is 17 raised to the power 1 by 3. Okay, it's a fractional power. Yeah, whichever root you're taking, whichever root, when you're actually doing that many, suppose in prime factorization, 2 into 2 into 2 you will have to take outside, then 1 2 will come if you take cube root. Yeah, just reminding you of that. Okay, in square root we don't write 2 here. It's understood when nothing is written at square root. That is written like this power. Everyone good so far? Everyone okay with this so far? Yeah, how we represent it in powers? Any questions here? How you represent roots and powers? Okay. Now, what is actually happening here is, so 40 ka prime factorization is what? 2 into 2 into 2 into 5, right? So basically what we can say is 40 is equal to 2 into 2 into 2 into 5 raised to the power 1 by 2. Now, obviously, if we take, we can write this as, we can write it like this, 2 to the power 3 into 5 also. But this power 3, what I will do with that? So I'm going to write it like this, okay? 2 to the power 2 into 2 into 5, okay? Everyone okay with this? I'm just clubbing this together. 2 to the power 2 is coming. Yeah. 2 to the power 2 into, this is what, 10, okay? Just going to write that together. So this together, this together. Now, there is one more exponents ka law which is needed here. Suppose you have a into b whole to the power m. What is that? Can someone expand this? Nishchay, I want you to go ahead with this. A into b the whole to the power m. How do you expand this?
Sir, A power M into B power.
Perfect. A power m into b power m. Okay, it's basically each substitute, each part of it I can multiply to the power m. So now here this is kind of A and this is kind of B. Okay. So what I can write is 2 square the whole to the power 1 by 2 into 10 to the power 1 by 2. Everyone okay with this so far? Any questions? What I did was A to the, so this was my M. Okay. This was my M and this was my A and this was my B. Okay. We're seeing this law playing out. Any questions? I want you to unmute and ask. Okay. I know that mostly I am speaking. This is not the usual way I teach, but it's just for recap and I'm trying to be quick. So if you have a question, you will have to unmute and speak. Assuming no one is unmuted, so I'm assuming you're good with this. Okay. So what happens here is, now this is an important thing to realize what is going to happen here. Okay. Let's take this separately. Okay. All twos are there, so it's going to be confusing. Let's take it as, suppose it was square root of uh, 25. Okay, then what would happen is it's square root of 5 into 5. So basically it's 5 into 5 raised to the power half. Okay, I'm doing a separate thing here. Okay, I'll come back to this in a bit because all 2 I took the wrong example. So this is what 5 square raised to the power half. Okay, can someone tell me how will this play out? This is of which form? This is of the form a to the power m whole to the power n. How will I write this one? Can someone? Okay, MG is raising his hand. Go ahead, MG. How do you think I'll write the 5 thing?
Sir,
Yeah.
5 power 2 into 1 by 2.
2 into 1 by 2. Perfect, MG. Okay. 2 into 1 by 2 will become what? That is coming.
2
Wait,
by
just 1 second. It's coming because this is nothing but a raised to the power m into n. Okay. So because of this, I'm writing this. So tell me now, MG, what will this become? 2 into 1 by 2 is in
5
the
power
power. Yeah.
5
5
power
power.
2 by 2.
2 by 2 is what?
1.
1, right? That's basically 5 only. Yeah. So this thing which had this thing will basically become 2, right? This 2 it will become. So I'm going to just demonstrate once again. 2 raised to the power 2 into 1 by 2 into 10 to the power 1 by 2. So this and this get cancelled. It's basically 2 into 10 to the power 1 by 2. That's basically what? 2 root 10. Yeah. I went a little bit here and there, but are we getting how exponents are working here? Okay. How exponents are working in when I'm taking root. How do we feel about that? Can I get a fist five in the chat box about this? Or a thumbs up? Yeah, fist five in the chat box will be better. -2, Dikshit? Oh, it was you were trying to answer previously. Okay.
Previous one.
Yeah. Sorry, I got confused. So Dikshit, since you have brought that minus ka exponent, I'll just remind everyone of what that is also. Yeah. But let's hear from Mansa. Mansa has a doubt, it seems. Go ahead, Mansa.
Sir, can explain how root 40 became 40 to the power 1 by 2?
This is just the way we write roots. Okay. Whenever I have root over any number, okay, it can be any number. Mansa, give me any number you want to give. Can you unmute and speak?
8.
8. Okay. So if it is this, okay, I can write it as, so this is basically square root. No, square root, like I'm taking, so when I'm doing it, what I will do, so suppose it's root over 2 into 2 into 5 into 5 into 3 into 3. Okay. What I'm taking 2, 2. This I'm taking out. From here I'm taking out 1. From here I'm taking out 1. Okay, Mansa?
Yes, sir.
In pairs I'm grouping. But suppose I had cube root, that is, suppose I had a 3 written here. Okay, where it will come from? X cube is equal to 8 means x is equal to cube root of 8. You get this concept?
Yes.
Yeah. So in that case, what I would have actually done is, in that case I would have written cube root of 2 in 8 is 2 into 2 into 2. Now these 3 2's will give me 1 2 outside. Okay.
Yes, sir.
Yeah, that's the meaning of cube root. Here we have the meaning as square root. Okay.
Yes, sir.
But I'm not writing that all the time. We don't write it all the time because when no number is written, it's assumed that it is square root only, because one root ऐसा कुछ होता नहीं है. There is nothing like one root. Yeah. So starts with square root only. Now, Mansa, if I the way of writing this thing which we have written in root form can also be written in exponent form like this. Okay. And the logic is what I just demonstrated here. If you take this as half root, okay, if you take this as to the power half, then you see I get the same answer by using laws of exponents,
Yes, sir.
like I will get if I used common root practice. Okay, what if I take just normal like this, what I will get final answer?
5, sir.
5 only. No, I'm getting the same answer here also, right? By using laws of exponents.
Yes, sir.
Got it? That's why root is root of something means that thing to the power half. Okay, Mansa?
Yes, sir.
Does this make sense? But that was a good question. You pushed us to think reverse of how this power half came. And for that question, I'm going to give you 5 points, Mansa. That power half was kind of the reason it came is because it fits. This is our common understanding of root. Okay. And when we think about it in power terms, the power half fits this logic and gives us the same answer. Therefore, we treat root as power half. Okay, Mansa?
Yes, sir.
Thank you. Thank you. Okay. Any questions about this, guys? We're good? Cool. So this was one part of the recap. Okay. There was another important part which I wanted to recap, which was um, the other part which I wanted to recap was rationalizing the denominator. Okay, rationalizing the denominator. Now this is actually, so suppose, so we all know that root 2 we just saw in in Monday's class, right? Root 2, root 3, pi. There are some other numbers also, but these are irrational numbers, right? These are irrational numbers. Irrational numbers have, when we write them in decimal forms, they will keep on going and they will not repeat also. So they are non-terminating and non-recurring. Okay, irrational numbers ka decimal forms. Now, because of this nature of irrational numbers, they are not preferred. We don't prefer that they are written in the denominator, because then you cannot, it's very difficult to compute an exact compute a decimal value, because denominator is only going on and on and on. The divisor is only going on. So the convention here, it's kind of a convention. It's a practice. Okay, not following this is not wrong, but we will follow it. Okay, the convention is whenever you get a number, say you get a number like 1 by root 2, okay, you don't leave it like this. Okay, in the final answer, you don't leave it like this. Okay, you can leave it in the middle, and you can just, if it comes in the middle of the answer and you just want to simply don't rationalize, that's okay. But in the final answer, when if you leave it like this, it's just not seen as good. Okay, so what you need to do is you need to rationalize the denominator. And for rationalize, I'll take a few examples of rationalizing. Just give me a minute, something is wrong with my eraser is not, no problem. So suppose the question is, suppose I came to a number which says 1 by root 2. What I need to do is, so I know root 2 is there. If I multiply it with root 2 into root 2, that will give me what? Root over 2 into 2. Okay, that will give me 2. One more way of looking at this same thing is, it is 2 to the power half into 2 to the power half. That's basically uh, a power m into a power n is equal to, anyone? A power, who's going to answer this? A power m into a power n is equal to a power, let's hear it from, okay, it's open. Mansa, go ahead.
Sir, a power m into
M?
into n.
Not correct, Mansa. Okay, we just saw where m into n comes. We had just
Okay.
seen that. That was
Then
when
m
it
plus
is,
m
when
by
it is
n
raised to
says
it, it is m plus m. What will come here, Mansa? A power?
a power m plus n.
Correct, m plus n. Okay, so what happens here? A is 2. Okay, the base 2. Power is 1 by 2 plus 1 by 2. That's nothing but 2 power half plus half is 1. So that's just 2. Okay, so when I get 2, so if I do, if I multiply any square root with itself, with its another square root of the same number, so any root x into root z into root x into root x, okay, I will get x. Okay, everyone good with this? Any questions in this? Okay, any questions? Just a minute. Dinesh is calling. Hi Dinesh, just hold on. I'll set up the phone thing for you. Okay, Dinesh, things are visible. Screen is visible.
Yes, sir.
Okay, were you here when I was discussing root 2 into root 2? Okay, Dinesh, do you understand what I've written here? Can you see this? Okay, let me quickly recap it for Dinesh, guys. Okay. All right, Dinesh, I have, so the practice, did you understand my introduction of rationalizing the denominator? Why we rationalize? It's just a common practice to not leave. Yeah?
Sir, at that time I dropped out.
Cool, cool. No problem. I'm just recap this for you guys. You can just continue to pay attention for a few minutes more. Dinesh, whenever we have something like 1 by root 2, okay, or 1 by 4 root 3, or 1 by 2 plus root 3, okay, in any of such cases, as you can see, the denominator is irrational, okay. Whatever the numerator is, 4 by 2 root 3, 8 by 4, it does not matter, whatever the numerator is. But if the denominator is irrational, we don't leave it like that in our final answer, okay. Maybe in the middle of the question you can leave it, but in the final answer, the general practice is, when you communicate the final answer to someone, is to keep the denominator rational, okay. So we are looking at ways to make the denominator rational, okay. This is a topic of last year. I'm just recapping that, okay. And I was just telling that suppose I have just a number root 5, okay. If I have root 5, if I have to make it rational, one simple way is multiplying it with root 5. Okay, obviously I cannot simply multiply, I'll have to multiply numerator and denominator. I'm just showing how it works, okay. If I do root 5 into root 5, it is root over 5 into 5, that's equal to 5. Okay, Dinesh? One more way of looking at it, I was telling exponent wise, is 5 raised to the power half into 5 raised to the power half. That's basically, how much is this, Dinesh? This is a to the power m into a to the power n. What does it become? A power m plus a power n. What does it become? Do you remember the exponent law? A power into. It does not become m into n, Dinesh. A power m whole power n is a power m into n. Okay. This is a power m plus n. Are we okay? All right. So this will become 5 power half plus half. Half plus half is what? 1. So 5 power 1, that's basically 5. Okay. I'm getting the same answer in the exponent root, and I'm getting the same answer in our normal square root. Okay. They're just showing that to everyone. Okay. And so what I was trying to do here, what I was trying to remind everyone here is, if I want to move this root 2, okay, I want to remove this root 2, what I need to do is I need to multiply it with root 2, okay, it will become rational then. But as you know, I can't simply multiply this with root 2, right? Then the number only will change. So what should I do, Dinesh? Multiply numerator also. Yeah, because if numerator is irrational, no problem, but denominator we don't keep irrational. Yeah, so this becomes what? Dinesh, can you tell me the answer? By 2. Perfect. Okay, and nothing happened. Okay, this fraction and this fraction are equivalent. Okay, but if we get an answer like this, we will convert it to this form and keep. Are we all good with this so far? Any questions? Any questions here?
No question.
Okay, cool. Just going to, so here also, here what do you need to multiply with? Anyone can raise their hands. Bindu, maybe you can tell. What do you think if I have to rationalize this one? Okay. If I have to rationalize the second one, what do I need to do? What do I need to multiply with? Bindu? What is your thought? Bindu, can you be quick?
Sir, I think we have to multiply it by root 3, sir.
Perfect. I have to multiply it with root 3. Okay, because 4 is already rational. I don't need to multiply with 4 again. So here 4 into root 3, 4 is already rational part. Don't worry about that. This part I have to make rational. So what I'll do, I'll multiply with root 3 in denominator and automatically
And also,
same with numerator. Very good, Bindu. So it becomes root 3 by 4 into root 3 into root 3 is what, Bindu?
3, sir.
3.
3.
That's equal to root 3 by 12. We all good here? So far? Any questions so far? Okay, now comes the little tricky example of how to rationalize the denominator. Okay, this third one is a little tricky, and I want you to pay good attention here. Okay, now in the third example, 2 plus root 3 I have. Yeah, here I'm going to use an algebra. So what I need is, finally I know if root 3 somehow, if I multiply it with root 3, that is if I do root 3 square, if somehow I am able to do root 3 square, then the denominator has a chance of being rationalized. Okay, that's my logic. And the simple way to do this is multiply it with the multi is what I'm going to do is I'm going to use the identity a plus b into a minus b. Can someone complete this identity for me? I would like to hear from Manisha. To Manisha, can you complete this identity for me? A plus b into a minus b. Let's see. Manisha?
Sir, a square minus b square.
Perfect, Manisha. Okay. A plus b into a minus b, if I do, I will get a square minus b square. So you see here b is root 3. It will become square, and there is no b term here, no simple b term here. So root 3 will not remain only. Okay, that's the logic I'm going to use, and I'm going to multiply. So I'm just going to write in the next line for ease of understanding. For rationalizing this, I am going to I'm going to multiply it with what then, Manisha? What should I multiply it with in the denominator?
Sir, no idea.
No idea. Okay, no problem. MG, you want to go ahead?
Sir, 2 minus root 3.
Perfect. 2 minus root 3. Okay. Manisha, are you observing what's happening in the denominator now?
Yes, sir.
Yeah, I'll come to the numerator part. So obviously I have to multiply this in the numerator also, 2 minus root 3, because I have to keep the fraction equivalent. I have to keep the numbers same. And hence what happens in the denominator? Leave the numerator part, okay? What happens in the denominator, Manisha? Can you do that? Can you do this here in the denominator?
Yes, sir.
Hmm.
A plus b.
A plus B, A minus B is already there, no ma. See, A and this
Okay, sir.
is B. Okay, and this is plus, this is minus. So A plus B, A minus B is already there. What happens if I have it that form? What can I change it to?
Square minus
2 square minus
root 3 square.
root 3
Root
square. Perfect, perfect. Root 3 square is correct. Yeah. 2 square minus root 3 square. What will 2 square minus root 3 square become, Manisha? Next line.
4, sir.
I'm going to leave the
4,
numerator. 4 minus
3.
3 over. I have rationalized. No, finally my denominator is 1, right? That's a rational
Yes.
number, right? Okay.
Yes.
Whatever is there in the numerator, just write it as it is. 2 minus root 3. You want, you can open this also if you want to open the bracket. So it will become 8 minus 4 root 3. 8 minus 4 root 3. Basically, denominator is gone only. 8 minus, denominator is 1 now. 8 minus 4 root 3, you can write just like that. Everyone good with this? I want to hear how are you feeling about this thing. Yeah. The same thing you have to do. Okay, let me first hear if how we are feeling about this. Okay, let me just check that. All right. Anyone has any doubts about this? Shri Priya, Dinesh, um, Manisha is good, I assume. Yeah. Okay. Deepak, any question?
No, sir.
All right. Great. Okay. Same exact thing I should do when the denominator has a term like this only, but minus is there in between. Okay. And let me take a little bit tougher example for that. Let's take the fourth question as, let's put anything in the denominator. Let's put 5 in the numerator, does not matter. By 2 minus 3 root 2. Okay. 2 minus 3 root 2. Now, any tips on how, any ideas on how, what I should multiply this with to rationalize it? Anyone wants to take that shot? Anyone wants to take a try at this? Same logic, okay? Same logic. A plus b, a minus b. If I have this format, I will make squares of both terms, and finally it will go away. Yeah. Okay, I see Nishchay, Riza, and Manisha raising their hands. All three have answered. MG, you have also answered. Would love to hear it from someone else. But let's go to Nishchay. Let's go to Nishchay today. Go ahead, Nishchay.
Sir, I'm not able to see the question, sir.
Here it is. Yeah. Now you're able to see?
Yes, sir. Sir, so
Tell
it will
me.
be 5 by 2 minus 3 root 2
That's as it is. I'm going to write. Yeah.
into
Hmm.
2 plus 3 root 2 by 2 plus 3 root 2.
Perfect. 2 plus 3 root 2 by 2 plus 3 root 2. Okay. Does not, now even though this is rational, sorry, even though this 3 is rational, but it's only the coefficient, it's only one part, this full number you should take. Okay. So if this full number I have to make as a rational number. Anyhow, this full number is also irrational. So I have to make this full number as irrational, and I'm going to use a plus b, a minus b logic and do that. So same thing, what comes in the denominator, can you clarify that for us, Nishchay? What will the denominator change to?
Sir, in denominator it will be 2 whole square minus 3 root 2 whole square.
Minus 3 root 2 whole square. Perfect. Can you continue solving the denominator for us?
Sir, it will be 4 minus 6 into 2. 12.
3 square is how much, Nishchay?
9, sir, 9 into 2.
9 into 2.
4,
Okay.
80.
What Nishchay is actually doing is 3 root 2 whole square is equal to 3 square into root 2 square. Yeah. Why a b the whole power m is equal to a power m into b power m. Okay. From there this is coming. All right. And that gives us 3 square is 9, or you can just write 3 into 3 into 2. That's equal to 18. Okay. And that gives us 4 minus 18. Denominator is 4 minus 18. So denominator is minus 14. Okay. You want, you can multiply it with minus 1 and minus 1 in the numerator and denominator and put this to the top, or you can leave it here also. That'll be your choice. Yeah. You didn't got it, numerator, same way you just continue with the numerator. 5 into 2 is 10, 10 plus 15, 5 into 3 is 15, root 2. Okay, and just treating root 2 as a variable here. Everyone good so far? Any questions about what we are doing? I want to hear if we have any questions about what we are doing. Yes, Dinesh.
Can you scroll up there?
Scroll up.
Scroll down.
Scroll down. Okay, last question. Okay. I'll give you time to copy right now, but any questions here? Nishchay, you're still raising your hands. Do you have a question, or is it previous thing only?
No, sir.
No question. Okay. Right. Okay. So now, see, now just one more important thing which you need to remember is when it is rational, when it is irrational. Whenever two, so if I'm adding irrational plus another rational number, it will be irrational. Okay, same way, irrational minus another number is also irrational. You remember this part from last year? Just open your last year's notebook and go. I would request you to go over this part when we get an irrational number, when we get a rational number. Okay, I would like you to go over this part, and so that you are able to recognize whenever you have an irrational number in the denominator. Yeah, that's one thing which I'm going to leave up to you to do. Okay, and I'm going to leave this on the screen now if you want to copy. I will be assigning a worksheet around this. Most probably I'll give you the same. I'll dig out the worksheet and I'll give you, or probably I'll just make a set of 5-10 questions of what we have done today, and I'll assign that. Yeah, it will be homework for today. I'll assign it by 3 o'clock. Okay, 3 or I'll try to do it before, but if I get late by 3 or 4 o'clock, 3 o'clock I should assign. Yeah, so that you have time to do it. Kishan, you have a question?
Sir, can you little bit
Little bit what, Kishan?
zoom it, sir?
Zoom in. I think you guys are able to zoom in